Hello everyone, my name is Fernando Rodríguez. I am an assistant professor at Universidad Rey Juan Carlos, and today I would like to talk to you about a project that I have done in collaboration with my friends of Universidad Politécnica. The focus of this paper is the measurement of the radiation pattern in a given angular cut of an integrated antenna, for example, the azimuth cut. And this is something that can be implemented by placing my antenna in an azimuth positioner. However, this creates some challenges when we are in the near field and when we don't have access to the reference channel of the antenna. This is what we are proposing, the measurement of a single cut using two different probes connected to the same receiver, so we can extract the relative phase between both. For this, we need to introduce the single cut transformation, which is based on an asymptotic approximation of the cylindrical wave expansion. As you can see in the figure, we are considering that the measurements are taken in a cylinder. However, this cylinder has an infinitesimal height, zero height. So if we introduce this constraint in our formulation, we will arrive to a mathematical relationship between the measured near field and what we call the single cut wave expansion coefficients. Now I need to express this relationship in a matrix vector product representation, and in a second step I need to express all the near field signals as a function of the phase information of the first probe, the amplitude measured by both probes, and the relative phases between the probes. With this, I will be able to derive a linearized system of equations that will allow me to solve the near field phase information of the first probe, and with that I could retrieve the radiation pattern of my antenna. After performing some simulations, we have observed that this whole process is very sensitive to any imbalance that may appear in the radio frequency measurement chains. So what we are proposing is a calibrated measurement procedure, which is based that in a first step, we are going to perform a measurement with a passive antenna with RF connector, so we can fully characterize this channel imbalance and obtain some calibration coefficients that we can apply to the subsequent measurements that we perform with the integrated antennas. And this has been tested at Universidad Politécnica de Madrid. As you can see, we have our dual probe system, our antenna under test, which in this case is an active phase array antenna that allows for different steering configurations. And in the lower part, you can see a comparison of the far field pattern retrieved by using our technique and the true far field pattern. So the agreement is excellent for all configurations. So as a summary, this technique offers the possibility to perform very fast near field measurements of antennas in which we don't have access to a reference channel. So with this, I would like to conclude my presentation and thank you for your attention.